Hi guys, nice to meet you. I should say so in front of the cam, am I right? No? Oh, okay. Hello Twitch. Today I would like to talk about a personal experience, a personal story. It's a really long story and it's based on DSL. And I think it's coming from childhood as well. I mean, more than technology, you have a kid or a human being behind ideas and stuff. So I'm Francis, I'm working for Dockler Holding. And why I'm saying that? Because I use domain-specific languages, this barbarian acronym, with a kid spirit and with the old quest of the engineer. The old quest of the engineer, this great utopia is, you know, to make configurable applications that could be expanded or refactored at any time without breaking anything. And the kid spirit is to build, virtual worlds, and domain-specific language, as we will see later, can help to do that. So let's start by the theory part. What is a domain-specific language? So it's just a mini language that is designed normally to answer a specific problem and to make it more readable, understandable, and by its restrictions, because it should have restrictions. I mean, it should not be Turing complete. With its restrictions, it allows as well to focus on the design problem. So this is not a DSL, but this is a good example for illustrating DSL, because we have a problem. We want to make a game configurable, and so we will use a config file with a config pattern that was designed to answer this need. So for example here, I should put the microphone next to my mouse. It's better now? Yeah? Okay, cool. So like that, we need to have dynamically at runtime or at compile time our level and our game design. So this is the problem. This is a model we want to illustrate, and we design a small language for doing that. So is XML, for example, a DSL, to continue this explanation? No, DSL is not a general purpose language. DSL, as we told just before, is just there to modelize this specific need or this specific domain. So for example, I took XAML. It's a good candidate for illustrating DSL, because it uses a general purpose language like XML, and it answers a specific problem like building interfaces, UI. So we have two kinds of DSLs, and they have kind of big discussions on what is an internal DSL, what is an external DSL. To summarize, the internal one uses a subset of your general purpose language. So if I use Haxe, I will use Haxe syntax, or a part or subset of Haxe syntax, and I will use it as an internal DSL. A good example for internal DSL is a fluent interface. So you are in the general purpose language, and you make an API for answering a specific problem. The other part is the external DSL. Some people say this is a real DSL. The fluent interfaces are no DSL. And so, as you can guess, it's a non-existing language. So it can be very accurate, because you can design it on purpose and imagine the right syntax for answering your particular problem. So another good example of external DSL, everyone knows CSS. It's a perfect candidate for illustrating that. So now let's talk about the quest. So why today I came for talking about DSL, and what is this long story about? So as I say in introduction, the idea and the utopia was to use domain-specific languages to describe application behaviors. And just in a simple way, and we will see why and how. So the idea is to split the code base and to describe with your general purpose language, so it's Haxe for now, some components, some brick of your applications. And with a second count base that will be described with your DSL, you will configure your applications, you will assemble it, and you will make it working. 2 code bases for 1 application. So, as you can see, this big dude now is scaled, and how his magic happens. So this is the purpose of it. We just modify the DSL, and we don't change the implementations. So 1 declarative way for designing the applications, and 1 imperative way to make the internals and the implementation. So why mon amour? So this is the story now. Once upon a time, so very far away, it was in 2003. I think it starts before, because when I was 11, I started programming, and I think my real fantasy was to design this alternative world. I discovered ActionScript 1. I was coding with other languages, so it was my first Flash date, and I wanted to imagine a system to describe objects and describe them at runtime. And it was a naive, very naive approach. The goal was to describe them with XML, and at runtime to reconstruct them and use them. So this is the first project, and it was called XML2 Object or something like that. Yeah, it was published on my blog in 2003. You remember that, Laurent? Yeah. In 2004, I wanted to push it forward, and I started to use AS2. And I imagined to expand this concept, to use XML protocol to make Flash configurable at runtime. So for the guys that do some Flash, you can recognize Flash API. And the idea was to reinvent it. It was in 2004, Flex didn't exist. So it was kind of the same approach, to have domain-specific language to redo some Flash and to make some websites or games configurable at runtime. After, I was very interested by some other technology, so to dig around and to see what was done. And I got some Java Spring inspiration, and I saw you could really push forward the stuff. And I was really interested, and I didn't know until this time there were some guys that use DSL and use in a strong way to make reusable applications. So it was the release of PixIOC in 2006, and the concept was simple. I mean, the big problem in engineering normally is the coupling, and the first goal of this DSL was to make coupling later as you can. You know what I mean? So coupling should not happen in my code base at any time, and should describe with this minified language at a later time. So the IOC principle, the inversion of control. And this is the Spring inspiration as well. So the story continues. This is the first version of PixIOC. It was released at first in AS2. And as you can see, the goal was to make this inversion of control. So for example, this movie lister needs a service, and this service is not inside the code base, is not inside the implementation. It's separated. It's in a declarative way inside an external file. So this is the first great advantage of DSL, and that's why I was really focused and interested by this topic. It's because normally with code, you have a time frame. You know what I mean? Even if it's object-oriented, you have a procedural approach. From step A to step Z, you should do the right thing in the right order. With this kind of approach, your system will build at some point, but you describe all the connections, all the relations you need, and your assembler, your DSL assembler, will take the role of the dirty job and assemble all your components in the right way for you. And there was this guy. Do you recognize this guy? No? Do someone know who is this guy? No? No one? It's Santa Claus as well, yeah. It's Martin Fowler, yeah. So there was this book that went to my bed, and I think many of you read this one, but there was this another one as well, domain-specific languages. And it brought me many, many ideas and to go further. So after, when you reach the way of imagining that you could build some DSL to make some applications and to have two code bases, why not to make the perfect and crazy system to invent a system that could create DSL? So there was this last guy in this love story. This is Haxe. I say 2016 because it was the release of Ex Machina, and we have a big part with DSL and porting PixIOC. But I think I started in 2015, maybe, Zubi? Yeah, something like that, yeah. So last year we presented this framework. And Haxe was a crazy discovery for me. That's why as well it's a user case and it's a personal success story. Because we have with ACE2 and ACE3, I got many tools for building that and doing crazy stuff. But Haxe brings me more. Yeah, Haxe brings me more. That's very cool. So I'm like a supermarket seller. Yeah. And Haxe can bring you more. Yeah. So what does it bring to me? It brings me to the power of making code generation. Because before, with the AS3 version, it was only possible to use DSL and to make assembling at runtime. But imagine now you invent, an abstract system with your DSL, as we see just later, and to make code generation. So you describe your application behavior with DSL, you still do the same, but you gain performances because your assembler doesn't do it at runtime, but generates the code for making it working. And there was this question, last year, after, WWX. Do we still need XML now? Because it's, Simon? Yeah, I see you say yes. And let's just take a simple example. This boy, this little value, you see how it's verbose in XML? And imagine now your DSL could be just this guy. Isn't it more, reduced and more readable and things like that? So it was my latest quest, to remove XML and to use Haxe syntax as DSL. So the question is now, is it internal DSL or is it external DSL? So it's a bit tricky because, so it's another example, It's a service map and with Haxe syntax, you see how it can compress. So is it internal or is it external DSL, to rebound? It's none of the both and the both at the same time. We will see why. So I went through that, and thanks to Martin Fowler, because he gave me some few best practices that I try to follow as an engineering kiddie. I split my code already before going for this big refactoring, and I already had parsers, So I just had to use Haxe feature with one line. It's super nice, You should use Haxe, guys. For that, just with this line, I can just take the content of a file and transform it as an expression and as a type IST. So, and with pattern matching, so I just had to transform my pattern. It was very easy, thanks for UI for the good tips, with expression verifications, for example. This is what could be inside my DSL, and I just have to match it with a really human, readable way for doing the right stuff and to make a method call. So Haxe was my best friend for doing that. And because I had previously a semantic model with all my DSL engine, as you can see, for example, this is the smallest part of it. It's an enum, and it's what I can do with my model. So it's very simple. I can do some preprocessing, build object, properties, and method calls. After, you can expand the engine. There are many repositories for that, but this is the small stuff. And because it was totally abstract, it allows me to use a Haxe syntax without reinventing the wheel around after with the semantic model and all the stuff. So it's in 3 steps, The parser, go to the semantic model, and after the factory methods that will build the final things. So indifferently a runtime application, because this is, for example, a factory to build an anonymous object, so it will build it at runtime. And if I switch it up, I can generate some code and just generate some code to have this funky anonymous object. This is it. And so, just to finish, I added more features because Haxe allows it. I could have a conditional parsing because it was already inside the context. I got this feature, so I could use it. I could add more flexibility as well. This one I was not so happy. Maybe this Haxe was a problem for it, because so what I wanted to have was runtime parameters. So you define your applications, and because it will be code generation, it will be compiled. After, you want to pass runtime parameters to modify this generated code. And for example, this is not valid Haxe syntax, so I just have to play a bit with regular expressions to make it matching. And another feature that I didn't have last year as well was to have Composite DSL. So for example, this is an application context, and the ID was to load another one with another protocol, for example, and to have a subword inside the main word, and to access them and to pass parameters and everything. And the latest one that I tweeted just a few months ago was the possibility to add custom parsers, and so to extend at any time your DSL. So this is an example. For example, I want to add a keyword in my DSL. I want to add the keyword sum to make some summing operation. And I can do it on the fly by just passing a custom parser or by passing many more. And this keyword now is able to act at compile time or at runtime. Another example with the Coconut, with the library. So at Dockler, we use Coconut. It's an advertisement. And we could add easily as well the HXX keyword in our DSL for using another framework and to make interoperability. So I got this question a lot of times. The last guy was, it was you, TB. No, Christian? Yeah, Christian. Yeah. Do we still need USL now that we have Haxe syntax in our DSL files? So I could answer that to you, Christian, because we didn't have this discussion yet. Yeah, because the primary goal, and this is the introduction of the talk, is to keep this separation of concerns and to have this small language that you cannot do some crazy things or do some internal implementations, small features, and more than that, this declarative way of connecting things. So this inversion of control pattern, like you express your things in disorder and you have many files that are related and linked to other, and your assembler has just to figure out how to make this fucking system working. And DSL, this is the conclusion, and I think this is the important part of it, can be a good friend if you have the right tooling. For now, I think we are not super 100% satisfied because we did so many additions and so many more developments, but we are on the right track. I mean, we will have to redo better error reporting. The previous repository and the previous projects has better reporting than this one. And another part of it, so error reporting is cool because you can have the right file position and the right problem described with understandable messages. And more than that, to have editors. For now, we have a Haxe develop and we have plugins. We have the XML plugin that is working super fine. I think I made some tweets about it, that you have code completion, that you have a code navigation and everything. And we are redoing the same thing with what we call the flow DSL, and it's just Haxe syntax. Yeah. So yeah, this is an example. For example, with the XML for auto-completion. As you can see, it acts like a general purpose language IDE. And that's it, guys. Thank you. And before going to lunch, here, just a quick word. Connect us if you're searching for opportunities to collaborate with us remotely or internally. Yeah. Thanks, guys.